Ratio problems can be solved by building a tape diagram. For example, in a previous video, a bucket with 20 chips has a ratio of 2 blue chips for every 3 red chips. The number of blue chips in a bucket can be found by building rectangular arrays with 4 columns of 2 blue chips and 3 red chips. A tape diagram is a shortcut for building rectangular arrays. For example, the number of chips in each row can be represented by the number 4 because each row has 4 chips. So, there are 8 blue chips and 12 red chips in the bucket. Note, each square in a tape diagram must have the same value. This rule for tape diagrams ensures that the original ratio, 2 blue chips for every 3 red chips, is maintained when the chips are replaced by the values in the tape diagram. The number of squares in a tape diagram represents the original ratio that is being represented. For example, there are 2 blue squares and 3 red squares in the tape diagram that represents the ratio of 2 blue chips for every 3 red chips. If the problem states that there are 20 chips in the bucket, 20 chips is divided by 5 total squares in the tape diagram to get 4 chips per square. Now, the tape diagram can be used to find the number of blue chips in the bucket, 8, and the number of red chips in the bucket, 12. Ratio problems where the number of chips of one color is known can also be solved using a tape diagram. For example, a bucket with 21 red chips has a ratio of 2 blue chips for every 3 red chips. In the tape diagram, the 21 red chips are divided by 3 squares for red chips to get 7 chips per square. Since each square in the tape diagram must represent the same number of chips, the 2 squares representing blue chips have 7 chips each for a total of 14 blue chips. This tape diagram also shows that there is a total of 35 chips in this bucket. Tape diagrams can be used to generate equivalent ratios. For example, the original ratio is represented by a tape diagram with 1 chip in each square. Equivalent ratios are generated by substituting other values into the tape diagram and finding the total number of chips for each color. Notice that the value that is entered into each square of the tape diagram is the multiplier that relates the like values in the original and equivalent ratios.